Hello, this is Professor White. This is a section about line graphs and scatter plots in the pre-algebra or beginning algebra level. So we're going to learn how to draw them and kind of read them and give you an idea about them. More detailed version of it is going to be in the statistics class. All right, so let's talk about line graphs. Line graphs are graphs that can visualize relationships between two quantities, one quantity horizontal, the other one vertical, and they're called line graphs. They have usually dots, and then the dots are connected with lines. One application is a time graph to show changes over time. You may have time on the horizontal and whatever changes on the vertical axis. Okay, so let's look at that. Let's say I want to have average World Cup goals per game, and I want to make a line plot of that. And I can have year this way, and I can have it this way. So let's say I start 1982, 1986, 1990, 1994, so every 4 years, 1998, 2002, 2006, and average World Cup goals per game, that can be the title. You can copy that. And this one varies from 2.2 to 2.8, so I can have a fairly accurate vertical axis if you want. So it doesn't make sense if I go 1, 2, 3 that way, and then everything will be all lumped up together. But I can kind of like, you might have seen this, like break the vertical axis and give some details. Let's say this is 2.3, 2.4, 2.5, 2.6, 2.7, and 2.8. You kind of force yourself to give some detail. And this one is goals per game on average. So that's a statistical number. That's why it's a decimal. 1982 is going to be 2.8. 1986, 2.6. 1990 is 2.2. Oops, I just realized I shouldn't have broken it 2.2 right here. I should have broken it right here, 2.2. And 2.7 for 1994. All right, 1998, 2.8 again. And then 2002, 2.5 around here. You may want to use a ruler, 2.6, 2.3. Okay, and then you go and you literally connect those lines. 1990 was not a good year. Does it make sense? Here's your line plot. If you want to see a better version of it, you may want to do the lines a little bit in this kind of, when I used Excel, it just passed a nice curve, but you can have it like abrupt changes, like that. This looks more like a V. Number of goals, year, average goals per game, so you have your thing all plotted out. Here's a line plot. It kind of shows the changes over time. Now I actually went and wanted to show you a scatter plot. A scatter plot is a plot to show the relationship between two quantities, and it's used, I call it a data dump, when you just don't know what the heck is going on and you want to look at the relationship between two things at a time. So this one is like, this one is the life expectancy, and I just looked at the per country. I just didn't want to look at the country where they're from, but whether or not there was a relationship between female and male life expectancies for any country. It doesn't matter. So these are actually real numbers. I think this is like 2000 number. I just went and got it from the internet. So I entered the female expectancy, male expectancy, And then this goes on and on and on. This is the real data. And then I just did a scatter plot. Okay? So I put the female expectancy on the x-axis, male expectancy on the y-axis. And now look at the shape of the graph. This is a scatter plot. I'm not passing judgment, but it is giving me great information. Watch. As the female expectancy rises, the male expectancy rises as well. So in a country where the females and males, if they are dying at a later age, if a female dies at a later age in a given country, female also dies in a later age in that country. Maybe it has something to do with the resources that country has and what they eat and health situations, but they live longer. Another thing that I can see from here is you see the females are here. They actually live longer than males. So it's kind of an interesting thing. And Excel put this thing in here, Series 1. You can actually label it, but there is no need for that. That is used usually when you have like two sets of data. You're looking female, male, and then kids or something, and then you put them all in one graph. So you may have different series or sets of data in that graph. But what this does, you go 65 years old is about 65 years of expectancy for a male. 82 years old, about 82 years of expectancy. But this one is a little bit higher for the females than the males. You cannot see that all that well, but what's important is that both trends are positively, it's going up. All right, so scatter plots are very handy tools to see the rough relationship between two data sets.